Hi students, welcome to physics class. In this video, we are going to discuss about some important points. That is, when the two vectors when the two vectors are acting, when the two vectors are acting in the same direction, in the same direction, what will be happen? Once again, today our concept is when the two vectors are acting in the same direction. This is the concept. Now take a vector. This is a vector. Now take another vector. This is B. Both are acting in the same direction. Then what will be resultant? The resultant is, now take, it is a vector A. Now B also associate with A, so that this is B vector. Therefore, the resultant is nothing but R vector. The R vector is equal to A plus B. The R vector is equal to A plus B. Once again I am repeating. Take a vector A which is positive x direction. Take another vector B which is also along the positive x direction. Now the resultant is, that is, take a vector along positive x direction. The B is added to A. This is from B added to A. That means the tail of B associated to the head of A. As a result, finally we will get head of B. So from here to here B, here to here A. The resultant R is equal to A plus B, gives A vector plus B vector. That means let the two vectors A and B, be acting in the same direction, Therefore, the tail of B vector coincide the head of A vector. That means then the single vector, single vector is vector R, drawn from tail vector A to the to the head of vector B or B vector gives their resultant gives their resultant give their resultant vector. Now once again I am repeating the point. Let the two vectors A vector and B vector be acting in the same direction. The tail of B coincide the head of A. Then the single vector are drawn from tail A to the head of B gives their resultant vector. Therefore, R vector is equal to A vector plus B vector. This is about when the two vectors are acting in the same direction. Now go for one numerical. Consider a particle is fast displaced through 4 meters due to east and then 3 meters due north. Let these displacement be represented by PQ vector and QS vector. Then find the final displacement of the particle PS vector is, this is the question. Once again I am repeating the question. Consider a particle is first displaced through 4 meters due to east, and then 3 meters due north. Let these displacement be represented by PQ vector and QS vector. Then find the final displacement of the particle PS is. This is the question. Now, solution. Now, solution. Take a vector along east direction. Consider it is east, it is west, it is south, and it is north. Okay, this is east, west, south, north. In this case, consider this is a vector P. This is a vector Q, PQ vector. What is the examiner given? 4 meters. Now take another vector, north direction. This is Q and S vector. How much? 3 meters. Now, what the examiner want? The examiner want P S vector. How much? That is the examiner want. Now take a vector that is PS. PS in this direction. Therefore, PS vector is equal to, what is the formula? According to Pythagoras theorem, because it is 90 degrees. Now, PS square is equal to PQ square plus QS square. That is 4 meter square plus 3 meter square. Therefore, PS is equal to 5 meters. This is called resultant. This is called resultant. So, therefore, PS vector is equal to how much? 5 meters. We have to solve the numerical like that. Now, next concept. When two vectors are acting, in opposite direction, what will be happen? This is the concept. Once again, when two vectors are acting in opposite direction, what will be happen? Now go for discussion. Now take a vector. This is vector A. Now take another vector. This is B. This is vector B. Now what is the resultant? The resultant is R. That means it is a vector A here, from here to here. This is vector B. Therefore, the resultant R vector is equal to, we can write it as A vector minus, so the total is A, B is in opposite direction this much. So that is A minus B vector. Now what is the resultant? The resultant R vector, the resultant vector R is equal to how much? From here to here only. From here to here. Okay. This is called R vector. That R is equal to A vector minus B vector. That means along the same direction but magnitude should be reduced. Along the same direction but magnitude should be reduced. Consider it is 100, it is 20. Here total is 100, opposite is 20. Now what is the remaining? 80. This is called that 80. Okay, we have to remember like that. Now go for discussion. Let the two vectors two vectors, let the two vectors are acting, in opposite direction. Opposite direction. Two vectors, let the two vectors, once again, let the two vectors, vector A and vector B, be acting in opposite directions. Now, tail of B vector, tail of B vector on the head of A vector, then the single vector are drawn from the tail of A vector, to the head of B vector, gives their resultant, that is R vector is equal to vector A plus of minus B vector. Once again I am repeating, let the two vectors A vector and B vector be acting in opposite direction. Tail of B vector on the head of A, then the single vector are drawn from the tail of A to the head of B, gives their resultant, that is R vector is equal to A plus of minus B. Therefore, the R vector is equal to A vector minus B vector. This is the right explanation for the when two vectors are acting in opposite direction. Now we are going to discuss about subtraction of vectors. Once again, we are going to discuss about subtraction of vectors. Now, go for discussion. At first, take a vector A. This is a vector A. Now take another vector B. That is in this direction, B. This is a B vector. This is A vector. This is B vector. Where is the resultant? This is the resultant. This is the result. This resultant we called as R1 vector. Now tell me, what is R1 vector? The R1 vector is equal to A vector plus B vector. Okay. Now tell me, what is R1 vector? A vector plus B vector. This is plus B vector. Now I want to take another vector from the head of the A vector opposite to the B in this direction. Consider, if it is B, this one we can call as minus B vector. If this is B vector, the opposite vector is called as B vector. This is B vector. Now I want to draw a resultant from point O to that one. That is like this. So this is resultant. This is resultant R2 vector. This is minus B vector. Now tell me, what is the R2 here? Here the R2 vector is equal to A vector plus, what is this one? Minus B vector. Therefore, the R2 vector becomes as A vector minus B vector. So, here R1 is equal to A plus B, R2 is equal to A minus B. So, this is the subtraction of vectors. Now, I would like to give the explanation for this one. It can be defined as the sum of two vectors A vector and minus B vector. Now, therefore, A vector minus B vector is equal to A vector plus of minus B vector. Therefore, the vector minus B is added to vector A to get a single vector, that is R2 vector. Therefore, the R2 vector is equal to A vector plus of minus B vector, that is equal to A vector minus B vector. This is about subtraction of vectors. I hope you understood this video. Thank you very much for watching this video.